Welcome to aminacademy.com. In physics, formula and their explanation, let us discuss about circular motion. A circular motion is defined as the movement of an object rotating along a circular path. Object in a circular motion can be performing either uniform or non-uniform circular motion. Motion of a car on a bank road, the motion of a bike, well of death, etc. are the example of circular motion. Now, angular average angular velocity. The angular velocity is the rate of change of position of the angle of an object with respect to the time, that is w equal to theta by t, where w equal to angular velocity, theta equal to position of an angle, and t equal to time. Now here this with respect to the center, the angle forms theta while the body moving from point A to B. That is omega equal to theta by t, angular, and theta equal position of the angle, time t equal time. Omega equal to s by rt, where s equal length of arc and r equal radius of the circle and time t. Omega equal to v by r. V equal to linear velocity, r equal to radius of circle. Then, therefore, average angular velocity omega average equal total angle of rotation, that is theta 2 minus theta 1 over t2 minus t1, which can be written as delta theta over delta t. This is a formula. Next one, relative angular velocity. Relative angular velocity is the rate at which the particle's position vector rotates in time with respect to a reference point. The reference point can be moving or at rest. It can be calculated by finding the perpendicular component of their relative velocity. Here, relative angular velocity, that is, suppose omega A to B equal velocity A to B and radius A to B. Next one, average angular acceleration. One more, instantaneous angular velocity at particular time, at particular position. What is its velocity? It's called instantaneous angular velocity, that is omega equal limit delta t tends to 0, delta theta by delta t equal d theta by dt. Next one, average angular acceleration. A formula for an average angular acceleration is a equal to change in velocity divided by change in time. That is a equal to w2 minus w1 over t2 minus t1. That is, average angular velocity is omega 2 minus omega 1 over t2 minus t1. Next one, angular acceleration omega 2 minus omega 1 t2 over t1. Next one, relative angular velocity. Here, relative angular velocity omega AB equal VAB over RAB. Next one, instantaneous angular acceleration. Instantaneous angular acceleration, which is equal, instantaneous angular acceleration is the time derivative of angular velocity or the limit of the average angular acceleration as time approaches zero. The formula for instantaneous angular acceleration is alpha is angular acceleration limit delta t tends 0 delta omega over delta t, which is equal d omega by dt, which is equal omega into d omega d theta, omega into by d theta. Next one, radial and tangential acceleration. What is radial and tangential acceleration? Here, an acceleration, radial acceleration is also known as the centripetal acceleration. That is, radial acceleration is the acceleration of a object towards the center of the circle, of the body towards the center. That is, a body rotating around the circle. It is centripetal acceleration is radial acceleration. Centripetal acceleration is towards the center. It is always perpendicular to the tangential velocity, and its magnitude is given by the equation. First, radial AR. Radial acceleration is AR is omega square R. Omega square R. The relation, this is radial acceleration equal to angular acceleration square into R is the formula. And further, we can say it is R, that is omega is V by R, the square, which is V squared by R. Means here V squared, this R down R squared, one cut, that is V squared by R. Here, tangential acceleration and centripetal acceleration are perpendicular to each other. This tangential acceleration is a result of a change in speed. Centripetal acceleration is a result of change in direction. The tangential acceleration. The tangential acceleration is the change in an object instantaneous linear velocity while its circular motion. It's tangent to the path of the object motion. Next one. Relation between angular variables. So far we discussed about the angular velocity, angular acceleration, but in the table, look at here. Here, velocity. In linear or transitional representation is V, that is V equal to R omega. Omega is angular velocity, so relation is V equal to R omega, where omega equal to V over R. Then displacement linear is S equal to R theta, and theta in angular representation is theta instead of s, and theta is s over r. Acceleration is a, that is a r alpha. Linear acceleration is a, angular acceleration is alpha. So a equal to r alpha. Therefore, alpha equal to a over r. Time e everywhere same. Force or a torque F, that is linear. Force is F equal to ma. It's a eta. Is eta equal to r F sin theta. Mass or moment of inertia is m here. And linear, m equal to F by a. And angular mass moment of inertia is I, where I equal to L over omega. Next, uniform circular motion versus non-uniform circular motion. Next one. Uniform circular motion is the type of uniform motion in a circular direction, while non-uniform circular motion is a type of non-uniform motion in a circular direction. The difference between the two is whether the speed of a body remains constant. Look at here, UCM, uniform circular motion, have circular motion with constant angular speed is known as UCM, uniform circular motion. But non-uniform circular motion, that is circular motion with variable angular speed, is called non-uniform circular motion. The speed is not same here. Then for uniform circular motion, angular acceleration is 0, but non-uniform circular motion, alpha is not equal to 0. Angular acceleration is not equal to 0. Then UCM, uniform circular motion, work done by tangential force is 0. Work done by tangential force is 0, but in non-uniform circular motion, work done by tangential force is not 0. For uniform circular motion is motion of the earth around the sun. For here, non-uniform circular motion, motion of a body on a vertical circle. Next one, centripetal force and centrifugal force. What is centripetal force? Centripetal force is the component of the force acting on an object in curvilinear motion, which is directed towards the axis of rotation or center of the curvature. Centrifugal force is a pseudo force in a circular motion which acts along the radius and is directed away from the center of the circle. Towards the center, it's a centripetal force. Away from the center, it is centrifugal force. Here, look at here, a car traveling around a circular path is this car want to go outward. So this force is centrifugal force. Centripetal force is a tangential to the circular motion. Next one, a simple pendulum. A simple pendulum is another mechanical system that moves in an oscillatory motion. It consists of a point mass m suspended by means of light inextensible string of length L from a fixed support as shown in figure. The motion occurs in a vertical plane and is driven by a gravitational force. Look at here. This is a fixed support ceiling. From that inextensible string is hanging. In that a bob, some mass is hanging. Now, if you from one end, from extreme one end, release the bob and it oscillates here uniformly. Look at here. This is the tension in the string. Look at here, mg is the mass weight of the bob. This is mg cos theta, same direction with tension. This is perpendicular to the tension force. Mg sin theta. This length of the bob is length of the string is L. Now we will we'll get the relation simple pendulum. Therefore, force is before that, look at here, T minus mg cos theta, that is a tension force here, mg cos theta, which is equal mv square by L. Therefore, T equal mg cos theta plus mv squared by L. Further, T equal to m, take out common, g cos theta plus v squared by L. Then force net force F net equal square root of mg sin theta the square plus mv squared over L whole square. This is a simple pendulum. In conical pendulum, a conical pendulum is a type of pendulum that spins in a circle instead of swinging back and forth. That means it's a circular. It moves like horizontal circle. It's made up of the weight or bob attached to the string of or rod that is suspended from the pivot. When the bob moves, it traces a circle and the string traces a chord, creating a conical shape. The bob moves at a constant speed in a horizontal plane, and the pendulum has two forces acting on it: gravity and the tension of the strings. The string's weight is considered negligible compared to the bob's weight. Now look at here. Here, bob is making a horizontal circular path motion. This is F cos theta, force upward, downward is mg, that is weight force. Here F sin theta, and radius is r, here height h. From that, conical pendulum will get some relations. Speed v equal r into root g over L squared minus r squared, L squared minus r squared over power 1 by 4, and tension T equal mgl over L squared minus L squared minus r squared power half. This is a formula for speed and tension. Next one, circular turning on the road. When a vehicle turns on a circular road, it needs a centripetal force to accelerate in a centripetal direction. This force is provided by friction between the vehicle's tire and the road surface. If the vehicle is traveling too fast, the frictional force may not be enough to provide a necessary centripetal force, which would cause the vehicle skid or move out of its circular path. For this reason, it's important to slow down when turning. But yeah, while turning, you have to take care about the speed as well as the bank of the road. Bank of the road is angle of inclination. When a road is banked or slanted, the ground's reaction also contribute the centripetal force along for a safer and turn at a higher speed. Now let us write by friction. By friction only, that means without road banking, then we can say V linear velocity is less or equal to mu or g, where mu equal to frictional constant between road and tire, r is the radius of the circular path, and g is gravity. So this must be lesser or equal to square root of mu or g. By banking, by road banking, road bank, by road banking you can say that is V max. V max must be, look at the formula, Rg mu plus tan theta, where theta is the bank angle, and over 1 minus mu tan theta. If they say minimum, V minimum equal to, say, Rg mu plus tan theta over mu minus tan theta here, mu minus tan theta over 1 plus mu tan theta. This is the two formulas. Note this point here. Next one, death well. It's generally a barrel-shaped wooden cylinder or with cemented. That's why it's known as the well of death. This is called well of death because it's having a lot of danger almost equal to death. There is a biker or a driver of a bike who drives the bike or a car along the vertical wall, little slope of the well, and shows different stunts. Look at this death of well. Death of well having some formulas, and mv squared by r. F equal to mg, wait, f, and f max equal mu mv squared by r. Cyclist does not drop down, that is cyclist or bikist. So know that here f max must be greater than mg, which gives mu mv squared by r must be greater or equal to mg. From this relation we can get it v is greater or equal to gr over mu. This is a formula for getting the speed, limit of the speed around the well must be greater or equal to gr by mu. Suppose this v, the speed is reduced while rotating, he will come down. He will come down means he may skid in the road. So far we discussed about different formulas about circular motion. We have done. Please subscribe our YouTube channel.